you'll be able to continue to type your answers in if you like for those folks. So thank you so much. That was fantastic. So let me adjust here. Okay, great. So next up we have Kasia Rachuta, a product analyst at Square, presenting first steps to transition from SQL to Pandas. Kasia, a reminder to set your timer. Enjoy.
Hi, everyone. My name is Kasia Rachuta. I'm currently a product analyst at Square. I'm going to talk to you today about fast steps to transition from SQL to Pandas. So a bit about my background. I graduated with a master's in theoretical physics from UCL in 2015. I moved to San Francisco for an internship soon after, and that's how I started my career in data science. And I currently work as a senior product analyst at Square, and I'm also a San Francisco PyLadies organizer, which is a meetup group for women who code in Python. You want to analyze some data. So what are some Python alternatives for writing queries in SQL? So you can actually hook up Redshift or Snowflake or any other database that you have into Python that might actually be quite time consuming, but it could allow you to write queries directly there. There's also a SQL module in Python, which I found when I looked into this, I found it to be a little bit underdeveloped. There's also Jupyter Magic and IPython that I couldn't quite get to work as well as I wanted it to. And finally, there's Pandas, which is arguably one of the most popular data science libraries that are there. So what are some advantages of Pandas? So with Pandas, you don't need a SQL database. So it's easy to use or any type of file you may need. So for example, CSV, Excel, even text files. There's been some other formats that I have used it on, but those are the most popular ones. There's also nice data visualization integration with other Python libraries like Matplotlib or Seaborn. And it's very well documented. So if you are trying to do something in Pandas and you get stuck, or if there's something that you're trying to do and you are unsure how, chances are that it's either documented or someone has already tried to do that. So you can look for their answers online. So let's start off with a data frame. So that's a Pandas table. Here I will be pasting screenshots from Jupyter notebooks. There are other IDEs out there that you may be familiar with. This is the one I use most often. And first I import Pandas as PD, which is the convention for imports, and I import NumPy as NP. NumPy is another very popular data analysis library. We'll be using it once, which is why I need it, but my primary focus will be on Pandas. And here I use DataFrame to import a CSV file called train.csv. So in this case, I will be using the Titanic data set. So if any of you have ever tried to learn logistic regression, you probably downloaded that data set and used it. It's available on Kaggle. So first of all, I'm going to do some data frame inspection. So dataframe.shape is going to tell me how many rows and columns we have. And dataframe.columns is going to tell me what different columns I have here in my data frame. So here we can see the list of passenger ID, whether someone survived, passenger class, and so on and so forth. And then finally, I also want to see what data types I have. So do I have integers, do I have floats, do I have strings, do I have timestamps? This is useful a lot of the time when something in the data frame is read as a string and you want to convert it to an object, to an integer. It often works, it's often very useful for timestamps where they are imported as strings, but you are wanting to convert them. So that way, you know that this is something that you need to do. And then we're going to look at some duplicates. So there's different ways of looking at duplicates. DataFrame.duplicated is going to return true or false on every row and every column and tell you whether that's a duplicate. DataFrame.dropDuplicates is going to drop those duplicates. Within that function, I'm not going to go into details due to time restrictions, but you can specify whether the whole row needs to be duplicated, whether it's one particular column that you care about being duplicated, and so on. You can also just look at duplicates within a particular column. So you just pick that column from the data frame, and it's going to return true or false, but only on that column. And you can also drop duplicates for that particular column. Doing this is not going to save the data frame with that column deduplicated. So that's something you're going to have to do separately, which I will show you how to do in one of the following slides. And then similarly, we want to look at null values. So checking whether something is a null value. So DataFrame dot is null, and this is outputting true or false to let us know whether something has a null value. And then we're dropping null values here. So DataFrame dot drop NA, and we can see again we're printing rows, and we don't see any null values. Now moving on, select star from table, the first kind of SQL statement. Because I use a Jupyter notebook, I can just say data frame and run this, and this is going to show me the data frame. Or you can do an explicit print data frame statement. In this talk, I will be just using this version, and I will not be using a print statement, which you may need to do, especially if you're using a different IDE than a Jupyter notebook. So here we can see this is how the data frame will be printed, which is already how we've seen it in the previous slides. Now I'm going to start with the simplest thing, being limit. So I arbitrarily pick the limit to be 7. So I do DataFrame.head, and then in brackets I say 7. So in generally, more generally, you can see that head, and then that by default gives us first 5 rows. But if you specify the number of rows, you can have 10, 100, and so on. And here we can see the first 7 rows, and here are our indices, which, as we know, indices in Python start from 0, which is why it goes from 0 through 6. So here is how we would save a new data frame. So I renamed this as new data frame, and then I equaled it to DataFrame.head7. So it's gonna save our new data frame as only the first 7 rows of our original data frame. And this is how you could be saving any other changes that you make. Now, simply doing select distinct on the embarked column from our table, I just want to see what distinct values there are. So I do data frame, I look at the column, and then I run the unique function. And then we're getting 4 different options. So S, C, Q, and none, which is null values. Here, I want to just pick select name from the table. And we can see that I do that by using data frame and then double square brackets name. Using double square brackets means that we will see a Pandas data frame. If we use a single square brackets here, that's also allowed, but we will output a Pandas series. So it really depends on your individual use cases. Now selecting on a condition, so now we want to look at passenger class being equal to 3. So this is the function that we run. So data frame, then inside the square brackets, we use data frame again, and we say that passenger class equals to third class. We need to remember to do a double equal sign in Pandas. That's very important. You can also use bigger than, smaller or equal, and so on and so forth, or not equal. In a very similar way, you just change this part of your code. Now doing mixed conditions. So if you want to use more than one condition, you can do that quite easily. So again, you do data frame, and then inside of your square brackets, you specify your conditions. Each of your conditions has to be in curly brackets. So here I want passenger class to be third class, and I want the sex to be male, and I just use the and sign. So here, quick inspection, this seems to work. Passenger class is third class, sex is all male. This works as we expect it to. You can also use an or sign. An or sign is the vertical bar here. And again, here we do an inspection, so it does seem to work. There's either passenger class is third class. We see there's first class, but that's male, which is the condition we want here too. Now, if we want to order by a particular column name, we do DataFrame.sort values, and then in the brackets, we specify what column we want to order it by. In this case, that's passenger class. And by default, the ascending condition is equals to true. So that's why I explicitly wanted to set it up as ascending equals false, just to show you that this is an argument you can pass. But if you want the ascending condition to be true, you just don't need to specify that. And then again, I inspect my data frame and check that this has worked correctly. Now I want to do some counts. So I want to pick the passenger class. I want to do a count star, and I want to group this by passenger class. So in DataFrame, we group by first. So I pick the data frame and then I group by passenger class, and then I pass the count function. So here we can see that we see those 3 passenger classes, and then it counts the number of entries in all of the columns that we have in our data frame. And one thing that you may already see that, for example, the counts are not equal in all of the rows. So you would expect that there will be 216 entries for fur and 216 entries for cabin. However, the cabin for first class only has 176 entries. This is because the count function does not count null values. And if you want to count those values, I will show you how to do that in a second. But before I do that, if you want to count something, you actually don't need to count all of the rows, all of the columns in the entire data frame. You can just pick what columns you want to count. So in this case, I care about passenger class, and I can count that by using passenger IDs. So I just specify that these are the 2 columns I want for my data frame. Then I group by passenger class, and then I do a count. So we don't get all of those columns in our output. An alternative here is to do data frame, group by passenger class, and then run the size function. And size function is a function that actually will count the null values. So depending on your use case, you can pick either count or size, depending on whether you want to count those null values or not. So now I want to look at sex, female or male. I want to look at the average age, and I want to just count star. So that means doing multiple aggregates all in one go, which is why we need NumPy for. So again, I pick the data frame, I group by sex, and then I add the aggregate function. And then in the brackets, I specify which columns I want what aggregate function to run by. So for age, I want NumPy mean, and then for sex, I want to do NumPy size. You can see that this gives us quite a lot of significant figures. You can specify that in Jupyter in particular about how many significant figures you want to see. That's not something I have the time to go into right now. Now we're going to do some joins. So as I mentioned, the Titanic dataset has like 2 parts to it. It's the trained dataset and the test dataset. So now I want to pick everything from the trained dataset. I want to pick everything from the test dataset, but I want to do a left join on test of the test data frame to the trained dataset, and I want to do that join on passenger class. Just to be clear, this is an arbitrary join that I picked for this example. It's not necessarily how I would really join this. We can see here that the syntax is PD, so we refer to pandas, then we merge, and then DataFrame is my first data set, which is the trained data set, and then test is my second data set. Then I tell it what I want to join it on, and how is using a left join. So by default, how gives us an inner join, so we can specify whether we want a left join, outer join, right join, and so on. And we can also join on more than one column. So here I just do a passenger class, but I could use square brackets to list out a number of columns that I would want to join it on. And this is our output. So we can see that there is kind of a suffix of X or Y if the column is duplicate. So that way we know each column, which table it originally came from. If we want to customize that, we can actually do so fairly easily. So here I run the same function with the same join, but I say that I want to have these specific suffixes, so underscore data frame and underscore test, so I know which tables they come from. And again, we can see this works very nicely. It shows us the data frame and the test tables that we actually can't see here. And then unioning is also fairly straightforward. So we create this new frames list that has DataFrame and test, and then we concatenate both of them. There is, again, a lot more customization you can do here that I don't have the time to go into. And here we can see the output. So now I wanted to show you some window functions, and I found a very millennial data set with avocado prices here. I think that was also from Kaggle. So here we can read the data frame avocado.csv. I inspect the first 5 rows just because it's good practice to have a look at your data set and kind of become familiar with it. And I'm going to do some window functions. So in SQL, this would be fairly complicated. This is a 4-day rolling average. And here I just pick average price from my avocado DF data frame. I set it a rolling 4, so it picks 4 rows, and then I pass the mean function over it. And we can see this performs as expected. So there is nothing in the first 3 rows because you can't do a 4-day rolling average without 4 days of data. And then on day 4th, which is index 3, the number starts to appear. And then we can also look at cumulative sum fairly easily. So again, here I will be looking at the average price cumulative sum, which in SQL would be this long window function. And this is our output. Again, I checked, I make sure that those numbers are increasing incrementally so that my function works as expected. So thank you. And I think now we can move to questions.
Fantastic. Thank you for the great talk, Kasia. We'll now transition to Q&A. Please remember to upvote your questions. Though I actually see one question in here right now, so I'll turn it back over to you.
Oh yeah, so the question is, how do I reach out to you privately? Feel free to find me on LinkedIn and connect with me or send me any questions you have there. Just let me know that you've heard of me through this talk. That helps. Thank you.
Okay, any other questions from attendees? If you have a question, you can post it in the Q&A. See, wow, great, really quickly about all of that information, so that's good.
Yeah, so the question is, will these slides be available? Will we have a centralized place for this conference to post slides on?
So slides will not be released. The content is being recorded. However, at this point, we can't promise that the recordings will be released to each speaker. So basically, it's up to you.
Okay, so I'm happy to put those slides on my GitHub, which is just my first name and my last name, all concatenated. Okay, more questions. This is great. When should we use SQL versus Python? So my rule is, if you have both of those tools available, is do and get as far as you can with SQL as possible and then transition into Python, simply because a lot of things are actually faster to do and run in SQL than they are in Python. But the other thing is, it depends which tool you're more comfortable in. It depends whether you are optimizing for speed. And obviously there are some things that are not possible to do in SQL, in which case you would transition to Python. But usually the way I work is I do some initial deduplicating, cleaning up of the data in SQL if the tool is available to me, and then I move into Python for any sort of more complicated analysis, any kind of A/B testing analysis, randomizations, modeling, things like that. One thing that I really like doing in Pandas versus in SQL is just using the describe function. So for those of you who are not familiar, if you use the describe function, it's going to give you a bunch of summary statistics on a column that you care about. So it will be all the quartiles, the mean, the count, and it produces all of that in one go very fast. So that's one exception that I make, that sometimes I just put data in and do that because it gives you an idea of the spread of the data. Are there things you cannot do in Pandas that are possible in SQL? Oh, that's a tough question. I don't know if there are things that are only possible in SQL that you can't do in Pandas. I cannot think of any right now. I know that some of them are just more complicated and time consuming in Pandas or in NumPy. Next question is, are there any learning online resources you suggest to practice learn Pandas and Python in general? So Python in general, there is a website called Learn Python the Hard Way, and that's also a book that you can buy. That's a resource I used. And if it comes to Pandas, I've learned a lot through Udemy courses, and I picked and chose a couple of those courses. So there isn't like one course that I use. I use a bunch of different things. And one of the things I would really recommend is go on Kaggle, download some data sets, play around with them. And other people also upload their code to Kaggle. And I also learned a lot through that, just seeing and comparing the way of things that I would do versus like how other people would do something. That was very informative to me.
Sorry. Sorry, I was just going to say we have to switch to the next speaker, but you can actually answer the questions through typing them in. So